This is question 2 of the chapter on residuals, variation, and diagnostics in the regression modeling textbook. The question 2 says refer to question 1, which is basically a rehashing of a question we've asked in numerous chapters, just restated in this one in case someone is starting this chapter without having done the previous ones. The question asks you to fit the model with kilometers, petrol price, and law as predictors. Then demonstrate that the residual variance estimate is the same as the one that R obtains, where you do it directly with the resid function. Let me get some space here, okay? And we want to, so recall, we normalized petrol price and we rescaled and centered the kilometers variables. So let's run the model, and the law variable is just a 0, 1 variable. So now we want to do the sum of the residuals from the output of our model squared divided by n, which is the number of rows of our data frame, because there's no missing data in this case, minus the number of parameters in the linear part of the model. 1 for the intercept, 1 for kilometers, 1 for petrol price, and 1 for the law variable. That's 4 parameters, so it should be n minus 4. So we get 522. If we do summary, that will print out many things, including the residual variance. But we can just grab it with sigma, and then we want it squared because it by default has the residual standard deviation. Of course, it's the same. This goes to show how R is calculating the residual variance and what the residual variance represents. It is merely the average squared residual, which represents the variability left unexplained after having accounted for kilometers, petrol price, and law. Again, we subtract off the 4 to achieve some statistical properties, namely the property of unbiasedness. You might have wondered, does my residual variance change by virtue of having normalized petrol price and rescaled kilometers? So let's do fit 2 and do it with petrol price and kilometers on their original scales. I would contend that the residual variance doesn't change because we have neither added nor removed information. We've simply changed the units of the variables in the regression model. If the regression model has any validity, that shouldn't change the amount of variability explained in our response. If we have a regressor that's in Fahrenheit and we change it to Celsius, we certainly haven't added any new information. That change shouldn't be allowed to explain any more or less variation in our outcome. So let's just double check and make sure that's true. Summary, fit 2 star sigma, $sigma squared, and you see that it's the same, exactly as we know has to be the case if regression is a valid procedure, which it is.